Hello, 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 and welcome back. Today we're going to be learning about standard deviation as part of our unit on working with one variable data. Today we are learning how to measure the spread of data, and we're also going to learn how to calculate standard deviation. You're successful at these skills when you can calculate using either formulas or technology, which includes spreadsheet technology or graphing software, when you can calculate and interpret measures of central tendency and measures of spread. And when you can explain when is it appropriate to use a measure of central tendency and when is it appropriate to use a specific measure of spread. To start off, I'm going to refer you back to this idea of the student getting a bunch of different marks on their various units. You can see all of their marks are here. What number could we give the student for their grade on their report card? So what one number would best represent all of their grades? Just taking a look at what the students' marks are on a chart, you might see that, oh wow, so in some of their assessments they scored really well. In other ones, they scored really, really poorly. So we're trying to find one number that can represent all of these 8 numbers. Well, I think we have to, what we're looking for here is something called a measure of central tendency. What is the way we can measure the center number that would represent all of this? And there's 3 ways, of course, that we have learned so far. There's mean, where I add up all of the student's marks, and I divide that by how many marks there are. So there are 8 different units. I'll add up all of his marks, and I'll divide it by 8, and that gives me a score of 80. So I'll give the student maybe an 80 on their report card. Another way we could represent it is by using the median. To use the median, we take all of their marks and we put them in order from least to greatest, and then we start canceling out the least and the greatest. So 49 and 100, gone. 68 and 100, gone. 69 and 92, gone. 71 and 91, we're going to average these two because when you have an even number of data points, obviously there's no middle number. The median will tell you what number is right in the middle, but because there are 2 numbers in the middle, we'll take the mean of these 2 numbers. 71 plus 91 divided by 2 is 81. Notice that this number is so close to this number, so it looks like 80 wouldn't be a bad choice. The last measure of central tendency is the mode, and that is the number that appears most frequently in the data set. And we can see that the number 100 appears 2 times, so some teachers might say, oh, you know what, this student, they deserve 100%, because they got 100% 2 times. They never got a 91 more than once. They didn't get a 68 more than once. This would be the most consistent. And I would say to that teacher, maybe you're being a little too generous, my friend. If by some chance there was actually more than one number that appeared exactly 2 times, so if this student got a 71 2 times and a 100 2 times, then you would just have 2 different modes, 2 different numbers that would best represent all of the numbers. So we can decide which number we want to use, but take a look at how different some of these numbers are. And in fact, take a look at how different some of the students' marks are. Is this student a really good student? We can see that they've got 100s, they've got 2 90s and 2 100s, but they've also got a 49. So we can't really say that for certain. We would say that this student's marks are sort of all over the place. And so the range of data, and this is another term that we do have to know, this is a measure of not central tendency, but this is a measure of spread, of how spread out the data is. The range is 51. And that's because between their lowest mark and their highest mark, there's a gap of 51 marks. What about this student? Can we find out what this student's marks are going to be, and which student between the 2 of them, which one's overall mark would better represent all of their grades. So which ones mark at their final report card mark, which one has a better a mark that better reflects the type of student that they are, their proficiency in all of their grades. We're going to do the very same thing here. We're going to calculate mean, median, mode, and range. But for this student, we can see that the numbers, they're a little bit tighter, they're a little bit closer together. So the mean is 79 plus 81 plus 78 plus 80 plus 79 plus 80 plus 81 plus 80. That would give us a total of 80. So both these students would get the same grade on their report card if we were taking the mean. If we looked at the median, let's see, we'll put all of these in order, and then we'll start crossing them out. 78 and 81, we'll cross out 79 and 81, 79 and 80, and then there's two more 80s. And so the median is 80 plus 80 divided by 2, which is 80. And finally, the mode, we can see that the number 80 appears 1, 2, 3 times, so that's easy. The mode is just 80. Finally, we'll look at the student's range. And notice that the highest mark the student got was an 81, but the lowest mark that they got was a 78. So the range is so small, and in fact, if we look at the chart, this student was sort of all over the place with the height of their bars. But this student, notice the blue bars are so much closer together. All of them are very close in height. This student is very consistent. So we might say that this student's overall mark, whatever we're choosing, it represents their data really, really well. Even though these two students might end up with the same grade on their report card, this student's grade on the report card better reflects all of their grades because all of his grades were really close together. None of the data was too spread out. So let's take a look at how spread out this data actually is. How erratic were all of these marks? What we can do is compare each mark to the student's actual mean. So let's look at these marks. So 92, how far is that away from 80? 92 minus 80 is 12. So this mark is 12 points away from the mean. A 91 is 11 points away. A 69 minus 80, that's also 11 points away, but it's less, so it would be negative. So we can't use the same calculation for all of them. Notice some of them end up being negative. And if we were to look at all of the differences, so what these numbers describe is the distance between each unit's mark and the student's average. And if we were to take the average distance, we would get 0. Because if you add up all of these, you would get 0. And the reason for that is some of them are negative. Negative 11 plus 11 cancels each other out, right? So instead of taking the mean, what we have to do is take these numbers first and turn them into positives, because the positives and the negatives right now, they cancel each other out. So if I just did this, if I just made these numbers from negative into positive, now if I take the average distance, if I take the mean again, I would get 15.75. What does this number mean? This number, 15.75, means that the difference between a single grade and the student's overall mark was 15.75% on average. Some of them were much bigger. Look at this grade, 49, that's 31 points away from 80. So this mark really doesn't reflect the student's overall average. The two are really far away. Some marks are a little bit closer, like this 71. 71 is pretty close to 80. It's only 9 units away. But on average, the student's marks were 15.75% away from their average. Now let's take a look at the other student. How far is this student's, all of their marks, how far are they from the student's mean? Well, 79 minus 80 is, what I'm going to do is I'm just going to take the positive number, okay? 79 minus 80 is -1, but I'll just keep it as +1. 81 minus 80 is 1. 78 is 2 marks away from 80. Then the student actually got a few 80s. So that is exactly the same as their overall mark. Then the student also got some more 79s and another 81 here. So if you take all of these numbers and you find out, okay, what is the average distance of each of their marks from the mean, you would find that that is 0.75. So this difference between one of these grades and the student's overall average is very small, just 0.75%. So what that might mean is that this 80 is really close to all of this student's marks, whereas this 80 is pretty far from all of this student's marks. This student was lucky enough that they had some really high marks to balance out their low marks, but this student's marks were all really close to their overall average. The way we calculated that was we took every single mark and we found the difference between that mark and the overall mean. And then from all those distances, we took the average. We use measures of central tendency, like mean, median, and mode, to find a number that can represent an entire data set. But we use measures of spread like range to see how close each data point is to the mean, or to the center of the measure of central tendency. When we have data that's normally distributed, and this is something that we learned in D1.7 and 8, when the data is normally distributed, there's another measure of spread, which we're going to learn about today, called standard deviation. Standard deviation measures how far each data point is, on average, from the mean. So we just actually did something like this. We just calculated that the standard deviation for those two students, for the student in blue, their standard deviation was, that the data points were really close to the mean. And for the other student, they were really far. A low standard deviation tells us that the mean represents all the data points really well. But a high deviation, to deviate from something means to sort of go really far or to change direction. And a high deviation means that the data is really spread out. It is not close to the mean. And this is what it might look like. So this is a normal distribution curve. And we learned about this in D1.5 and 6, right? Here is the mean, that is the center of the data. And if all the data is sort of like, if most of the data is near the mean, we would say that this is normally distributed. This is what it might look like if something has a high standard deviation. So notice that the data is much more spread out. Not a lot of data. So notice how short the peak here is. There's the data is a little bit more spread out here. This would represent that student who in red or in orange. You can see their marks are all over the place. They did not get a lot of marks that were close to the mean. Whereas this student has a really low standard deviation. You can see that most of their marks were really close around the mean. And so most of their marks are representative of the mean a little bit better. The distance, the standard deviation, is the distance between the mean, and you can see there are these notches here. So this is like a medium standard deviation. This is a low standard deviation. This distance is very, very small. And this is a high standard deviation. This distance is very, very big. Data points that are in a normal distribution follow a very special rule called the 68-95-99 rule. And what this means is that in a normal distribution, 68% of the data falls within one standard deviation. So if I take the mean, if I calculate how big is a standard deviation, and I add that to the mean, that'll give me an upper limit. And if I subtract it, that will give me a lower limit. And that 68% of the data will be within those two limits. 95 means that 95% of the data falls between two standard deviations. So if I add the standard deviation 1 2 times, and I subtract it 1 2 times from the mean, then I can see that most of the data in this curve, most of the area in this curve is with this green and orange parts, right? 95% of the data is underneath this section right here. Notice the rest of the data is very, very small, very, very low. There's not a lot of data that is very far from the mean. And that's why this is also called the 68, 95, 99 rule, because 99% of the data falls between three standard deviations. So the mean plus the standard deviation 1 2 3 times, and the mean minus the standard deviation 1 2 3 times. 99% of the data will fall there. And this keeps on going. There's 4 5 6 standard deviations, but the further you get, the higher the standard deviation is, the less data will actually be in that, that very extreme end. So basically, in our previous lesson, we learned about histograms, and we learned that they can take this shape that's sort of like a hill. When that happens, you can calculate what is one standard deviation, and I'll give you the formula for that in a second. And then you know that 68% of all of the data falls within one standard deviation. And that means the mean minus one standard deviation, the mean plus one standard deviation. So to give you a very quick example, those students that we just looked at, student A, their mean was 80%, right? That was their overall average. But we saw that their standard deviation was about 15.75. So this plus 15.75 is 95.75. And if we subtract 15.75, we would get 74.25. So basically, 68% of this student's marks, or about 2/3 of their marks, fall between 74 and 95. Most of their marks, they had 8 different units. About 6 of those 8 units will fall, or 5 of those 8 units will fall between 74 and 95%. So there are 3 different types of measures of central tendency. There's mean. That tells you the number that fairly represents all of the data all at once. The median will tell you the number that is in the middle of all of the data. So it doesn't necessarily represent all the data really well, but it tells you what number would be right in the middle. The mode will tell you the number that occurs most frequently in the data. And there are 2 measures of spread that you will be required to know. There is the range, which tells you how far apart the extremes in the data set are, so the highest and the lowest numbers. And then finally, the lesson for today is the standard deviation. The letter we use, the variable that we use to talk about standard deviation, is actually a Greek letter, and it's shaped like this. It's called sigma. Okay? And so the standard deviation, whatever the value of sigma is, that tells you the limits that have 68% of the data, 95% of the data, and 99% of the data. And this is how you calculate standard deviation. You take each data point and you subtract it from the mean. We call the mean x bar. And each data point is just x. So you take every single data point and you have to subtract it from the mean. Then, remember how some of those data points ended up being negative and we wanted to make it positive? An easy way to make it positive is to square them, so to multiply them by itself. 2 negatives would make a positive, 2 positives would make a positive when we square them. And so, not only would we get positive numbers, but whenever you take a big number and you square it, the number is actually way bigger than if you take a small number and you square it. so that those differences between the data point and the mean actually get blown up to be bigger and bigger. Then what you're going to do is for each of these squared differences, you're going to find their mean for all of them. If you're using a sample instead of a population, so if your data set only includes a few members of a population, you will actually, instead of dividing by the number of data points, you'll divide by one less. So if that student had actually had 100 units that they did, and we only looked at 8, when we're finding the mean of the squared differences, we wouldn't divide by 8, we would divide by 7. And then you're just going to square root that number because we squared it, so we're going to do the opposite now, and that would tell us what is sigma. That will tell us the amount of one standard deviation. We can take that number and take the mean of the data, x bar, and subtract sigma to find the lower limit, and add sigma to find the upper limit of what is the range of one standard deviation. Below is a data set of 10 D10, which means a D10 is a 10-sided dice, and we rolled 10 10-sided dice. How many times did we roll them? We rolled it 12 times. So this represents one roll of 10 D10. This is a second roll, and so on. What is the standard deviation of this data set? And what does it actually mean? Well, to find out, the first thing we do is find out what is the mean of the data set. We find x bar. And x bar is taken by taking all of these numbers and dividing it by 12. And that gives us 51. So the average roll when I'm rolling 12 D10 according to this experiment is 51. My next step is to subtract this number from, subtract my roll total, each data point, subtract 51. So 52 minus 51 is 1. 56 minus 51 is 5. 45 minus 51 is negative 6. And then remember, so this number represents how far each data point is from the mean. You can see that most of them are pretty close. This one is pretty far. So this roll must have been really, really bad. It was 15 lower than my average roll. And these last two rolls are pretty good, 59 and even 61. That's my highest roll. This represents how far each roll was from the mean. So now let's square that. We'll take these numbers and we'll square them. 1 times 1 is 1. 5 times 5 is 25. Negative 6 times negative 6 is 36, and so on. And so you can see here that not only did this, by squaring it, not only did I make the numbers into positive numbers, but any numbers that were really big, like 15, when I square that, I get a really, really big number, 225. So the differences are also sort of magnified. So these are the squared differences. And so we will take this number and we will find the mean of all of them. So I'll add them all up and I'll divide it by 12. Now, because I only roll this data 12 times, this is what's called a population. So I have no other data that's not represented here, so I'll divide it by 12. But if I had actually rolled it 120 times and I was just looking at 12 random rolls, then this would be a sample and I would only divide it by 11. That's what the difference between a sample and a population's standard deviation is. Either way, I find out that the square differences are 53.16. And of course, we don't want sigma squared, we want sigma. So I will square root both sides. That will cancel out the square. And when I square root this side, I'll find out that sigma is about 7.29. This is one standard deviation in this experiment. But what does it mean? That means, and notice that I could have done all of this work a lot faster if I had a spreadsheet. This spreadsheet has all of my rows here. And all I do is I put into a different cell a formula equals STDEVP, STDEVP, standard deviation of a population. And then in the formula, I just put all of these numbers from A1 to A12. And when I press enter, it'll automatically tell me that the number is 7.29. So I don't have to do all of this work. All of this work is for you to understand sort of what is the process and what does it mean, right? What is a standard deviation? But a formula can do it for you in one step. And this is what it means. The lower limit is we take the mean, which is 51, and we subtract the standard deviation, so that would give us 43. And the upper limit is x bar plus sigma, the mean plus a standard deviation, which will give us 58.2. So this means that if this is my distribution curve, the mean is 51, one standard deviation lower is 44, and one standard deviation higher is 58. And that means that 68% of my rolls, so about 8 of my 12 rolls, would have fallen between 44 and 58. 68% of my rolls were between 44 and 58. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.